Containerization is for simplifying development and deployment of applications, and as you'll see, also development environments. The definition you'll find out there in the internet is that to containerize is to bundle an application along with all of its associated dependencies into a single object or container. So why is this bundling of an application important? What does it achieve for us? I have these categories that I'll talk just briefly about for the merits of containerizing. One is portability. So this is really the main one that you'll see people talk about. But if you containerize an application, that means it can run on multiple operating systems. The operating system just has to run some kind of container runtime, and any container can therefore run. Reliability is another benefit. So this is very related, but once you have a correctly containerized application or development environment, it's going to work the same in principle on all the machines that are able to run it. And this is really important, especially when I get into talking more about containerizing a development environment. If you can imagine, if you're on a software team and let's say you have some new hire, you now can, instead of having to get their environment set up so that they can build whatever your software product is from source, and anybody that's been on a large scale project knows how painful that can be sometimes. My old company had a famously horrifying onboarding experience where it took people, it could take 3 weeks or more to actually get your environment to a point where you were able to build, just with all the latency and bureaucracy of a big company and trying to get IT to help you out and all this. So this containerizing your development environment ideally lowers that to approximately zero effort. You just have an environment that is an image, and the new developer can use that image to get up to speed and be able to build the product immediately. And it'll work just the same as it's working for any other developer. So you hopefully shouldn't have too much troubleshooting to do with regard to like custom nuances about that one person's environment. Scalability is another one, and this is really relevant to once you're deploying your application. If you're trying to scale your application, let's say across multiple bits of infrastructure, you want some redundancy or resiliency for your product. There's a lot of ways you can do that. If your application is containerized, it's really easy to use what's called a container orchestrator, like Kubernetes or Docker Swarm or something like that, to kind of orchestrate your application across multiple nodes. So those tools like that do a lot of the heavy lifting for you in terms of scaling your application across infrastructure. There are security implications for containerizing. So each container is isolated from other containers, and also even from the host machine on which the container is being run. And that isolation is really, it's in line with the principle of least privilege, right? Where you are trying to give as few privileges as possible to the processes that are running, which is a good security practice. Simplicity, this is another obvious benefit here, but once the container, once you have an application or an environment that is containerized, I hope to show you today that it is extremely simple to run, and it really lowers the threshold for running applications and also contributing to projects if the container is for a development environment. The last one, the last category of benefit here that I want to talk about is documentation. This is something I don't really see, but it's just a benefit that I have noticed myself by working with containerized applications. But the container is like a configuration file. Let's say you're using Docker to containerize. Well, then you have a Docker file, and that Docker file serves essentially as exact instructions for how to set up an environment to run an application. So just by having a working container or image, you have effectively documentation for exactly what you need to do in order to get something running. And so that is a great benefit as well. And so as I've said, you can containerize development environments. How do you do this? Microsoft has fairly recently come out with something that they call their dev container specification. And the way they describe that is that it allows you to use a container as a full-featured development environment. This is one approach. It's the approach that we are making use of. I think right now that VS Code is the only actual IDE that supports this specification, but the idea is that it is not actually tied to VS Code. So I hope that in the future there will be additional IDEs that support this specification, and then anybody that is using this specification to containerize their development environment anybody who uses any of the IDEs that support it will be able to use your containers. So the dream really is that anyone can contribute to anything from anywhere on any hardware with any OS at nearly native performance, which is a tall order, a big dream, but I think it is actually happening. And this is the same tech that powers Microsoft Codespaces and Gitpod. And yeah, it is great for decentralization because of what I said before, how it lowers the barrier to people actually contributing to your project if they can very easily spin up an environment that lets them contribute. So what are we containerizing? We are containerizing the Sybase build environment that's done, the development environment, the CLI tools for Sybase and Synode, which I am going to show you today. And also we are looking at how to best containerize the deployment infrastructure for Sybase. So that is the infrastructure that you would use if you were actually trying to deploy it on a live server. Like, for example, the Sybase.io deployment that's live today, that is running in I guess just a Docker Swarm config, but it's all containerized basically, which made it very simple to deploy and maintain. The container images are all on our GitHub. So the GitHub has a container registry, GHCR, GitHub containeregistry.io. So if you go to GitHub and you go to our organization, go Fractally, and you look at packages, you'll see various packages we have. And these are the images that you would use to launch containers for various use cases. So one of them is, I guess the relevant ones would be Synode and Sybase, which are the CLI tools, and then the Sybase Builder, Ubuntu 2004 and 2204 are the build environments for Sybase on each of the respective operating systems, Ubuntu 2004 and 2204. All right, and that's it for discussing the fundamentals, but I actually do want to now show you a couple demos, first of the CLI tools and then of the actual development environment. So what I have here is I'm on my Windows PC, and I have a console up within VS Code. And I also, what you can see above here is I do have a couple aliases that I've made in my bash RC. But so you can see when I type Synode, it's aliased to this whole command. So let's run through that real quick. The first up to here, basically, that I have highlighted, these are all parameters that I'm passing to Docker, right? So I'm saying Docker run, remove name Synode. These are optional. You can look up what those do in Docker documentation if you want. This is relevant. I'm putting it on a Docker network called Synode Network, and I'm going to do that when I use both the Synode and Sybase CLI tools so that they are able to communicate with each other. I'm forwarding port 8080 on the host to port 8080 in the container. And then the last parameter here for Synode is the image. And the link to the image is just the GitHub containeregistry.io/gofractally/synode and then the version number 016. Once you have this very minor setup, and you don't even need these aliases, you can type that manually if you want, but what it means is I can, on Windows, essentially use Synode as though it is a CLI tool that I have locally on my machine. It's actually running it inside a Docker container, as you saw, but it feels like it's running right here on my Windows machine. And that's really cool because it's not designed to run on Windows. That's pretty cool. I will show how to actually run it. So Synode is actually running right now, and it's waiting for you to boot the chain. But I can actually go to, if you go to admin-sys.sybase, you can see all of the configuration stuff that is made available. So this is before a chain is built. This is part of Synode, but Synode is serving these to the browser here, and it lets you configure your node. It's set a block producer name, set a host where this is accessible. But that was it. So in about 1 second, I was able to run the Synode infrastructure. 1 more second, as I'll show you, it's just as easy to actually boot the chain. So similarly, I can run Psibase right here as though it is a native application, even though it's running through Docker. And what I want to run is the boot command. So I can run. All right, so now that the chain is booted, I can go, for example, to Sybase, the host address that you saw in the configuration. And there you go. You can see that the chain is running. You can look at the block explorer and see blocks propagating away. Obviously, there's 0 transaction in each block because nobody's using this local development chain. But with just 2 commands, basically the Synode command running through Docker and then a Sybase boot also running through Docker, I can now run my own local development chain here on my Windows PC very, very easily. And it's complete with front ends, a front end for configuring the node, and various default front ends that come stock with this Sybase infrastructure. That is very simple, and I hope it is useful to you, but probably if you are a software developer, what is more useful is actually the containerized development environment. So that is the next thing I want to show. The way to use our containerized development environment is that we have this Sybase contributor repository. This is on GitHub and it's public. And I've already cloned it, but basically you would clone it to your local machine and open it in VS Code, since VS Code is the only IDE, I believe, currently that supports the dev container spec. And basically the Sybase contributor repo is basically some set of configuration files that gets read by an extension that you need to install in VS Code. So this is really the only prerequisite, is that your VS Code, you have to have VS Code, and then your VS Code needs to have this dev containers extension. And I suppose you also need Docker on your machine. But provided you have met those prerequisites, all you have to do is clone the Sybase contributor repo to your local machine. The configuration files will all show up here. And then from within VS Code, you can simply run rebuild and reopen in container. Now, for you, this is going to take a little while. If you've never done this before, it has to pull the images, and the images are pretty big that it's pulling from GitHub. I've already done that. So for me, and for this demo, this should only take a few seconds. All right. So we are looking at inside VS Code. It has now opened the Sybase repo inside a container, and that container contains the entire environment you would need to develop Sybase. So all the dependencies, it even includes some shortcuts down here at the bottom that you can see. This, for example, the first thing you probably want to do if you were doing this on your own machine, you want to do a full build for as basically the first thing. And so you could click that button there at the bottom to do a full build. Nothing magic's happening. If you go into VS Code, tasks.json, you can see what the command is that's running when you click any of those buttons. It's really just configuring CMake with various flags and then running make install. So we use the CMake build system, but yeah, I've already built for this demo, so I don't have to, we don't have to sit here and wait for me to complete a build, which takes a while. But by just cloning a single repository that we have publicly available, having VS Code, having the dev containers extension, and opening this in a container, you now have the ability to just out of the box build from source Sybase and Synode. And since I've already built, I can show you what that looks like and show you some other bells and whistles that this has. So I'll just run, but this time it's not running a Docker command to run Synode and Sybase. This is just, I'm just directly using the executables that are built and live inside this container. So I can run Synode DB just like I did before. And you can see VS Code helpfully tells me that my application is available on port 8079. And I will also run the Sybase command. Transaction timed out. So let's see if the chain is booted. I believe it's booted, actually. And it is producing blocks. So in fact, the chain looks like it did boot successfully. And so something that I want you to notice here, which you might be surprised about, this is a secure connection. So if you run Sybase and Synode through this development environment, it is actually extremely easy to get an HTTPS connection to your local Synode chain that you have running here. The only thing you would have to do that I didn't show you, basically on your local host machine, so this is on my Windows machine, not inside the container, I've cloned Sybase contributor. Inside Sybase contributor, there's this local certs folder, and you would need to install the rootca.pem, or if you're on Windows, rootca.pem.crt, and that will allow your browser to accept the certificate, the SSL certificate that is generated and used by Synode. So all of that's generated automatically. So basically, once you launch the container, you can just go look in that local certs directory and you'll see the PEM file that you can install on your OS. And of course, in here, you have all the same configuration options you had that you saw in the Synode and Sybase CLI tools. In fact, this is a little newer because I built from source here. So you're getting the very latest Synode and Sybase. And I can even show that the dashboards work. So in order to get the dashboards to work, you actually do have to run admin dashboards. You just run that from within the container, and then we should see that a Grafana server is running, and that will give us some very nice looking dashboards that help you monitor the performance and goings on of your node. Okay, and what you're looking at here is all the stats and metrics of your locally running development node as aggregated by, well, as displayed by Grafana. And it's aggregating that from Prometheus. We have our logs filtering through Prometheus, and Grafana is grabbing them and organizing them into these graphs. So all of that gets done and deployed for you. So it's very simple. And you can see the memory consumption, the CPU usage, reads and writes, page faults, etc. And that is the end of the two demos. And that will bring me to questions.